Asia Chapter 2025, or as we fondly call it, Nice TEAS 2025, Asia. I am Nirhangma Subba, and it's an absolute pleasure to moderate today's online session. This international conference is jointly organized by the Banking Academy of Vietnam, Hanoi, Vietnam, and Apex University, Jaipur, India, supported by Shree KKarni University College, Jaipur, and managed by KK Consultancy Services, India. This year, we received an overwhelming response with over 400 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. And based on these performances and the recommendation of our session chairs, the selected papers will be published by Springer Nature. Yesterday, on 29th of October, the day one of the conference we had was an incredible series of keynotes, paper presentation, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity. And that was offline in Vietnam. And as we step into day two, we carry forward the same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I'm pleased to introduce our session chair for this segment, Professor Paras Kothari sir. We welcome you, sir. And before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. Number one, each presenter has 7 to 8 minutes. Please stay within the time limit. Number two, a short reminder will be given to you 6 minutes to your presentation. I'll be giving a short reminder after 6 minutes that only 1 minute is left for your presentation to complete. Number three, briefly cover your research context, objectives, methodology, key findings, and conclusion. Number three, a short Q&A may follow your talk of 1 to 2 minutes. Keep responses very brief and focused. Number five, keep your mic muted when not speaking and stay for the full session to support the fellow presenters. And now, with the kind permission of our session chair, we shall now forward with the paper presentation. So, I would like to invite our first presenter for the day, presenting the paper title, Paradigm Shift in Educational Landscape with English as a Programming Language, under the code 375. I request Ma'am Jayati Basu to kindly take the virtual stage and begin the presentation. Over to you, ma'am.
Okay, good morning and good afternoon, everyone. I'm Jyoti Basu, and it's truly an honor to be here today to present our work titled Paradigm Shift in Educational Landscape with English as a Programming Language. This research is done only with collaboration with Ayush Jaiswal, Boishakhi Laha, and Shomshubra Gupta. Shomshubra Gupta is our mentor. Now, if we come to our introduction part, let me begin with a thought that started its whole journey. We live in a world surrounded by technology. Almost in every field, from education to business, depends on software. Yet the brilliant creative minds cannot create the software by their own. Why? Because because of the programming barriers, because of the hard programming languages. It feels like foreign languages. If you think about it, before writing, even a simple hello world, you must remember the syntaxes, must remember the complex code, the keywords, and even more complex for the new learners. And for many learners, it's where the programming already stops before it even begins. This problem becomes even harder for two kinds of people. First, those who visual and cognitive challenges, and most tools are built in the complex visual and dense symbols. Programming adds an extra burden with their learning with English grammar and also with the syntax of the hard programming languages. And even for the average learners, it's a huge cognitive load. So one day with some cup of tea, we asked a very simple question. If programming doesn't feel like programming, if people just write their thoughts, describe the way they want to explain the in simple English, and computer could understand the simple English, could understand what they actually want to relay with their ideas using the simple English. This single question become the actual seed of our research. Our vision is just not to simplify the coding, but to make the programming human crafted, more human created, and even more engaging, regardless the background, the language, the eligibility. To explore this idea, we began some design and we create some framework that could take plain English and plain introductions and plain executions also, then and turn them into logical, structure, and executable actions. Now, if we come to our technical approach part, here how we imagine the workings, and when user writes something like very normal, like create a list of five numbers, find the sum of the numbers. The system first reads the clean text and break them into some, what are the verbs, what are the nouns, what are the pronouns, and all, and it understands the intent, what we actually want to do, what we actually want to relate by our sentence. Next, it build the internal or global structure which represent the logic behind the sentence. Finally, it converts the logic into some executable code that can run. If, in short, I can explain, it's like a simple sentence of English, then a structured code, and then the logic, and then the code, and then the actual output. The main result of our research is like the teaching our computer or teaching our system is to learn, is to listen, and is to understand the English, but in structured and predictable way, not through an AI guesses, through the definite linguistic and the logical mapping of the system. This approach could completely change how people interact with the technology. It means a student who struggles with the syntax could still explain the idea naturally, see them and sit with other friends and work with their ideas very fluently. It means some with vision limitations and could give the spoken and typed commands without worrying about the curly braces, the keywords, the syntax, whatever the actual languages or actual programming languages wants. It means that the programming becomes less about the remembering syntax and more about expressing the logic, the real essence of the computation. Some insights in our research from this study, we gained several insights. We realized that programming is not about only uh, some coding lines. It's only about the thinking, the clarity of the idea. If a person can explain the idea is already done with the logical part. We just need a system that can translate our idea very easily without any kind of hustle, without any kind of bugs into code. But there are kind of limitations also. We saw that accessibility are not extra. They must build into the design from the beginning. Then the tools are more easier to understand, then open the door for a new kind of idea, for new kind of exploration or new kind of creations and all. And finally we understand the future of the programming. It will not only about the automation, it will not only about the AI and all, it also about the meaning, about helping computers to understand what we actually want to mean, not just what we type or what we copy and paste. No, nothing like that. There are some limitations also. Now, this work is still conceptual. We had no kind of design system on hand. Our designing prototype and framework ideas are on hand. till now. And after this, we just want to test how well it happens from learn, and how well it help people to learn to create the real sitting, like classrooms with friends, with exploring their ideas and all. And our long-term goal is clear: to make the programming accessible, multilingual, inclusive, so that it truly becomes a tool for everyone, for the not just for the experts who can only learn with their experiences, and then they can code something kind of software, website, and whatever they want with their ideas. Now, I come to the conclusion part. Uh, what we are actually proposing from our research, that is like from syntax to semantics, from rules to reasoning, from learning code to expressing the ideas in a way. This work takes programming back to the original part. Like programming is the main focus point to communicate with the machines, to communicate with the systems. But there are some barriers of the coding languages, syntaxes, many kinds of commas and keywords and all. That's a huge burden. So our vision is simple. Our vision that one day programming will not be something only for coders or programmers. It will be something anyone can do, because it will speak the world's most natural language, English. Thank you.
Thank you so much, ma'am, for your presentation. It was really insightful. Thank you so much, ma'am. And now we are open to questions, if any. If there's any question for ma'am, we are just open to questions right now. I think there's no question, ma'am. Or is there any question, sir? Okay,
No,
okay.
not from my side. We can go forward.
Okay. Thank you so much, ma'am. You may stop presenting the screen, ma'am. Now, I would like to invite our second presenter of the day, presenting the paper titled From Artificial Intelligence to Generative AI in Academia under the code 366. I request Sir Som Shubhra Gupta to kindly take the virtual stage and begin the presentation.
Yeah, ma'am, my co-author Shaurya Gupta will present this.
Sorry, sir?
My co-author Shaurya Gupta will be presenting this.
Okay, 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 sir.
Yeah.
Sure.
Shaurya, get ready.
Is my screen visible?
Yes, it's visible.
Okay, thank you. Good afternoon to the chair and delegates attending the TEAS 2025 conference. I am Shaurya Gupta, and we're presenting the paper Evolution of from Artificial Intelligence to Generative AI in Academia, co-authored by Dr. Som Shubhra Gupta. So through this presentation, we'll go through that how artificial intelligence has evolved from a simple rule-based system to advanced generative models, and how this evolution is actually shaping the academic landscape at the present, and also what are the future scopes. So let's begin at the roots. AI, or artificial intelligence, the main aim of AI is to make machines capable of thinking and acting rationally, taking decisions from data itself with minimal human intervention. Early AI aimed to simulate the living intelligence, whether it be human or biological behavior or the problem solving skills, as we can find in nature, such as ant colony optimization or bee colony optimization or particle swarm optimization. So AI at its core basically sought to replicate the problem solving behavior we see in nature. However, as time progressed, researchers realized that simply programming intelligence wasn't enough. There was a need for machines to tackle real-world uncertainties and biases to produce better predictions and make more sound decisions. So that's why with time, AI evolved from computer literacy to AI literacy. Other verticals and sub-verticals of AI also developed, like soft computing, which includes fuzzy logic, neural networks, and genetic algorithms, all inspired by uncertainty and adaptability in real-world systems. And also we have machine learning, which is a data-driven approach where the machine actually learns from the data rather than explicit instructions provided by the programmer to solve a problem with better accuracy and finesse. And then subsequently, deep neural networks also introduced and were extended to solve much more difficult real-life problems with better predictive capabilities. So coming to the machine learning, it is essentially a subset of AI. It enables systems to learn from data, decode patterns, improve performance without explicit programming. So the main two types of machine learning are supervised learning and unsupervised learning. So supervised learning is used on labeled datasets. So that means dataset in which we do have already some idea about the target variable or what we want to achieve. For example, if we want to find out sales of a company in a quarter, or whether email is spam or not spam. So basically what supervised learning does is it finds a function that almost near accurately maps the input variables x to the output variable y. So basically it does a function approximation. Unsupervised learning, on the other hand, figures out patterns, and it's used for datasets which are unlabeled. And based on the patterns, it finds correlation and similarity among the datasets and tries to group them accordingly. But the main drawback with ML was when trying to find patterns, or rather complex patterns from real world data like image, texts, and other audiovisual media. So the overall performance of ML didn't impress much. So that's why it was necessary to rely on a more biological inspired approach. And that's why the neural networks came into the scene. Neural networks basically is a reflection of human brain, that how human brains process information and how they reach to a conclusion or decision. This consists of interconnected units called neurons, each performing simple operations but collectively producing intelligent behavior. The network learns by adjusting the weights and activation function across input, hidden, and output layers. And this structure allowed AI systems to recognize and classify patterns, a major step towards traditional ML. Then we proceed with the deep learning, which is a subset of machine learning, and it is basically an extension of the neural network conception with multiple hidden layers. And it is capable of recognizing complex data patterns, faces, expressions, emotions, voice tones by processing massive data sets through multiple abstraction levels. This approach is currently the backbone of majority of the applications that we see in the present day world, like natural language processing and computer vision. So till now, whatever the models we had, AI models, machine learning models, deep learning models, we noticed a sharp improvement in their predictive powers, but none of the models were generative in that sense. So they could not create something new. And that led to the rise of the generative AI. Generative AI represents a major paradigm shift from predictive intelligence to creative intelligence. It combines algorithms to detect and replicate data patterns. The core components include generative adversarial networks, autoregressive CNNs, and transformer GPT models. And it is widely used in defense, healthcare, tourism, manufacturing, and education. The generative adversarial networks have mainly two main components, the generator and the discriminator. The generator creates synthetic data, and the discriminator evaluates whether the data is real or fake. Both models compete in a zero-sum game, continuously improving each other's performance, and the generator produced output is considered accurate when the discriminator is no longer able to clearly identify the fake data or discriminate it from the real ones. GANs are widely used in image synthesis, data augmentation, then text-to-image generation, anomaly detection, and even in healthcare simulations. So these are the applications of generative AI in present-day world. We have e-commerce and content recommendation for personalization recommendation systems. It is widely used in product design and visual arts. In scientific research, it finds application in simulations and hypothesis generations. In healthcare, it is widely used in drug discovery, diagnostics, and medical imaging. Then in education also, it helps in tutoring, it helps in coding and debugging support as well, data synthesis, interactive resources, and etc. Here we see some of the emerging generative AI tools that are reshaping the academic practices. Platforms like ChatGPT, GitHub, Copilot, and Google Gemini are supporting personalized learning, brainstorming, and coding assistance. Teachers are using these tools to create interactive lessons, automated grading, and provide real-time student feedback. In many ways, GenAI is becoming a co-educator. So this slide here highlights the tools that expand creative and research capabilities in academia, from AI-based writing assistant to diagram generators to translation tools. So overall, the AI tools are helping in enhancing the productivity and creativity, whether it be for educational purpose, study purpose, or research purpose.
Pardon me, sir, for interrupting you, but you have got 1 minute to wrap up the presentation.
Yeah, sure. We'll jump to the conclusion directly then. And to conclude, the study reviews the evolution of traditional AI to generative AI, highlighting how each stage from learning to creativity has transformed and how it is influencing the academia. In future, obviously, smarter algorithms would be developed, and the use of AI would obviously make the academic improvements much more relevant and accurate. But the ethical responsibility should also be kept in mind, and fairness and creativity must remain at the heart of the AI development. So these are the references that we used for our study. Thank you, everyone.
Thank you so much, sir, for your presentation. Now we are open to questions. If there's any question for sir, you can unmute yourself and just question. Okay, so I don't think so there's any questions. So we'll be moving to the next presenter of the day. So I would like to invite our third presenter for the day, presenting the paper titled Isolation Enhancement of Circularly Polarized CPW FIT Monopole MIMO Antenna for 5G Spectrum Sensing Applications under the code 388. I request Sir Pachianan to kindly take the virtual stage and begin the presentation. Over to you, sir.
Good afternoon, sir. Good afternoon, madam. Madam, kindly share my PPT, madam. Myself, I have to share, or yourself is sharing my PPT?
Sorry, sir.
Can I share my PPT presentation mode, or you can share my PPT? That's my doubt.
So you can share your PPT and explain. It's fine.
Yeah, 2 minutes.
Yes. Sir, are you facing any difficulty for the presentation?
Yeah. Is visible, madam? It's
Uh,
visible or not?
it's visible, sir.
This time that is next slide is not moving. That's what I'm checking.
So what you can do is refresh the page and again present it, sir. I think there's some
Yes, yes,
technical glitch over there. Yeah.
yes, madam. Thank you.
Sir, are you able to present your screen now? It's visible, sir.
It's the slide is moving, madam.
No, sir, your slide is not moving.
I think you are not in presentation show. Let's check on.
So now it's moving, sir.
No, sir, it's not moving right now. Would you like to present it after some time, sir? If there's an issue. Okay, sir. Now it started moving. Yeah,
Yes, please, ma'am.
sure, sir. You can begin with
Yeah.
the presentation, sir.
Yes, good afternoon to everyone. This is Dr. Pachianan from Vignan Foundation for Science and Technology and Research, Dept University, Andhra Pradesh, India. My research title is Isolation Enhancement of Circular Polar CPW Fluid Monopole MIMO and 5G Spectrum Sensing Applications. So why I chosen this title for this conference? Because nowadays the system is running with fast data rate transmission. Especially for the fast data transmission, there is a device that's a antenna required to take the communication between the user and other different portfolio. For that purpose, I'm proposing new antenna for the 5G spectrum sensing application. Apart from it's beyond 5G also we can able to propose the same structure. We can able to go for a 6G application also. That's what I chosen this title for these conferences. So what are things I'm going to explain today? My ideas means so that I'm going to give my how I did my designs and what are the parameter I consider and what are the requirement for the MIMO systems and how it will be useful for the for this conference thing and also I'll only give the conclusion of what is the future scopes. So this is the main thing I want to convey what is the necessity of the my proposed work is. So usually we want to communicate data between the user. Usually better we can give the better data connectivity and also if you want to go to better connectivity, we need the device. The device they can able to handle for the some distance. Which means we can take from 100 meter to up to 1500 meter. Maybe we can take for the Wi-Fi connection or Bluetooth connections, and or we go for long distance communication in terms of kilometer we can able to go. For that one we need antenna. That antenna mainly that we can go for the calculate the how much the gain. Basic gain we can go for the distance we can able to calculate, and also bandwidth also very important, and what direction the waves are transmitting. This is the main thing I chosen this topic, and also why I brought the MIMO structure means nowadays MIMO playing important role for the for mobile network communications. The reason is MIMO it means multiple input multiple output. For example, 10 input you are giving, 10 output you are getting. Maybe output side we are unable to get the out of 10 we are unable to get the 9 inputs. So at the time, what we'll do, the remaining antenna is act as a single channel. Maybe it will be detecting the remaining antenna signal. It can be collect and also give the better. It can able to give the better results compared to the remaining things. Which means After 10 antenna result, we can able to see and at a time, and also better result, better signal strength we can able to provide the users. That's the main motive. We are going to, you can choose the MIMO technology. There is a, which mean at the theoretical level, I taken 1x2 MIMO anna, which mean 1 row, 2 columns. So in practically we can go for which means 32 elements, 64 elements. If you go to large scale system, if you go to mobile network and all, they are using 64 to 64 element MIMO antenna they are using. In large scale, if you go to radar system and all, they are using 128 and 128 element they are using. Based on the gain, we have to calculate. Generally, how to gain calculate means single antenna gain plus 10 lakh base to 10 base to the 10 of number of elements. So from this manner, we have to calculate the total gain of the antenna. We have to calculate. So for that one, I am proposing 1x2 MIMO monopole antenna, which means monopole antenna is omnidirectional pattern. We have to it will provide. So my application, I want to communicate to all the directions, which means entire 360 degree I have to cover. And also it will go for the circular polarization, which means it will operate both linear polarization and also circular polarization. It can any azimuthal angle this antenna it can resonate. That's the thing. That's what from that from the aim I made this design. The structure of the single antenna design 30 into 27 into height, which means height of the substrate 1.6 millimeter. And also for that this single antenna again it provides 2.77 to up to 5.01 gigahertz. It provides center frequency 3.9 because for Indian standard and the South Asian standard, the 5G frequency there's a different NRL band they are operating. So for the 5G frequency, we can center frequency 3.9. It will operate from 3.2 to up to 3.9. Sometimes we can 3.2 up to 4.2 gigahertz also we can operate. So maximum bandwidth we can give 400 megahertz bandwidth. Narrow band requirement is 140 megahertz frequency. 140 megahertz. That's a narrow band requirements. Wide band we can able to take maximum up to 400 megahertz frequency we can able to do it. So same single element I made converted into multiple elements. That's what the MIMO concept came here. The MIMO characteristics are I analyzed it in this work. The ECC, which means envelope correlation coefficient and directive gain. I calculated. I confirmed that whatever I proposed that is suitable for the MIMO structures. So this is a structure I designed. First I took what happened. No, first I took ground layer. Bottom ground layer is there. Above the ground there is a substrate layer. What is substrate? I used FR4 material. Above that FR4 material, I used a monopole structure. That's a monopole antenna. It is lambda G by 4. That means lambda G quarter wave length for the frequency of 2.4. Which means for the frequency, which means I am using here 3.5 because 5G frequency. For the conventional method, I used first I started with the 2.4. Later I made length. I calculated lambda G4. I went to 3.5 gigahertz. That's my record frequency. So this is a dimension. Antenna dimension. Table 1 indicate the antenna dimension, width and length. Everything I calculated mathematically. I calculated everything. Later I used a high frequency structure simulator. To the simulator I designed my antenna. I got the result. The result is the figure number 2 showing the about the return loss plot, x-axis frequency, y-axis return loss plot. So minus 10 dB, I taken the reference. Why minus 10 dB mean? Because there will be getting 10% will be reflected back, 90% will be transmitted. So that center frequency will be getting around 3.5. It will be very, which is narrowly, it's matching with exactly, which means exactly matching with the 5G band. So it may cover the entire 5G spectrum. That's what my title given, 5G spectrum sensing application, which means it cover the entire 5G. And also it's working circular polarization, which means from 3.2 to up to 4.2, it will cover the entire band, and also it will operate circular polarization. So which means whatever the frequency, the data will be which means resonating, transmitting entire azimuthal angle, which means 0 to 360 degree azimuthal angle, the data can able to transmit, which means it will be resonating. That's what indicating. The figure number 3, how the impedance matching, because impedance matching we can of course real and imaginary part. So 50 ohms we have to match real part. Of course you can refer my structure on the figure number 3. The matching with the 50 ohms, which mean black color lines are real and imaginary line is 0 ohms. R plus JX, real and imaginary part. So real for 50 ohm and then 0X, which means imaginary part. So reactive component and capacity component should be match equal mean. That's mean zero mean. It's called say resonating mode. That's what theory telling. So this is a single antenna structure design. Now same single antenna I told circular polarization. Circular polarization how to evaluate, how to calculate with the help of axial ratio. The axial ratio less than 3 dB how to maintain. Of course, my antenna showing less than 3 dB. So ultimately it's showing it's a circular polarization. This antenna resonating 3.2 gain. What is the gain of the antenna? The 3D model I given here. It's only direction radiation pattern. It will give 3.2 dB gain. So now I'll move to the MIMO antenna structure. I kept two antenna. So just to refer the slide number here, this slide 3, here 4. I'm given here two antenna. I kept orthogonal pattern. Why I kept orthogonal mean the isolation have to improve. Yes, of course, we take different antenna. Not only that, what is important mean? If you go to number of failing mode, there is interference between the antenna. So to avoid any electromagnetic interference, you have to keep our antenna with some distance or some technique to apply to segregate the which means to avoid any electromagnetic interference. So for that motto, I made two antenna. I kept in orthogonal polarization because orthogonal pattern antenna that which means the electromagnetic interference is less. How to find out mean? You can see here figure number 8 S21 and then S12 indicate the how much isolation is there. Of course, so greater than minus 15 dB isolation is there. See, which indicate very clearly there is no electromagnetic interference between the port 1 and port 2, which means antenna 1 and antenna 2. So there is no electromagnetic interference. Isolation is more. So it's working independently. It's working very independently.
So, pardon me for interrupting you, sir. So you may wrap up your presentation in 1 minute, sir.
Yeah, yes, madam. And also I given figure number 7. I given the prototype model because not only simulation model, I made prototype model. The prototype model I went to the simulation, which mean I compare with my measurement device with the help of VNA vector network analyzer. With the help of vector network analyzer, I verified my simulation result is exactly matched with the real-time system, which means showing very good result. Which means the simulation result and measurement results are both are matching. That's what indication figure number 9 showing the isolation between the two antennas. And also for that one same whatever the single antenna gain, same thing MIMO antenna also getting same gain 3.2, which means both antennas which mean giving the 3.2 gain. And also this another parameter is called MIMO, so multiple input multiple. This is ECC envelope correlation coefficient between the two antennas, which means we have to maintain the 0, which means ideally 0 value. So almost I have to maintain 0, which means 0.01 is coming. 0 to 1 you have to maintain ECC value. So almost I'm getting the zeros 0 to 1. So it's a matching with isolations. And also directive gain also DG have to maintain almost 10 dB have to maintain here. So almost I'm maintaining the entire spectrum. I maintain the same thing. This is what I compared with my proposed antenna with the existing antenna, because any system we have to whatever antenna, because this is not a new technique or new novelty. I'm not applied whatever thing, but my structure, my design is new. So my design is compared with the existing systems, so that my proposed antenna will giving a very which means the ECG is very less and isolation also very good compared to the previous existing antenna, and operating frequency also very good. The bandwidth will be more. That's what, because you see compare with my antenna, because my antenna, I propose my antenna say very compact. So ultimately, if I refer last row, 30 into 80 mm, this my antenna showing very, which means very compact, which means compared to the existing antenna, and also which is very essential for the 5G spectrum, 5G spectrum sensing applications, and also very compact and also giving very good gain, and also omnidirectional radiation pattern it's providing. This is what I want to give my conclusion. So ultimately, I want to give my conclusion. My MIMO antenna provide the good gain and very compact size, and also good it providing good isolation, and also suitable for the which means 5G spectrum 5G spectrum sensing application. We can use same technique we can use, and we can apply for the 6G technology also. So this is what I want to conclude. For the future scope, just I want to go for the apply for different mathematical concept, and how to improve the gain. If you want to improve the gain, we have to apply the different technique. You have to go for the different structure, and we have to go for the 6G technology entrance. Okay, these are the paper I referred during my work. Thank you, sir. Any questions, sir,
Thank you
please?
so much, sir. Thank you so much, sir, for your presentation. We are open to questions now. Uh, from the audiences or from the chair, anyone, if anyone has question, please go forward. Okay, seeing the fact we don't have any okay, do we have questions? Yes, sir, please.
No, I think we can move forward. That's what I.
Okay. Sure, sir. Okay, so now I would like to invite our fourth presenter for the day, presenting the paper titled Beyond Labels, a self-supervised learning paradigm for scalable and semantic information, retrieval in heterogeneous data corpora, under the code 394. So I request Sir Virendra to kindly take the virtual stage and begin the presentation.
Ma'am, my presentation is visible.
Yes, sir, your presentation is visible, but then the presentation is not open, sir.
Just a minute. Ma'am, it is visible.
Yes, sir, it's not visible right now.
Okay. Hello, I am Virendra Tam. I am PhD scholar from Tata University, Shree. Today, I am excited to share my research review paper on Beyond the Labels, a self-supervised learning paradigm for scalable and semantic information retrieval in heterogeneous data. Now, some abstract is now in recent year, the world has the largest consumption of the data, often referred as the big data. This rapid growth of the data present the both opportunities and challenges for the various industries like healthcare, finance, marketing, and technology. A vast amount of the structured and unstructured data being produced every day. The information retrieval IR system, which are designed to search, organize, and retrieve relevant data from the large data set. Now, self-supervised learning, which is label data, a popular machine learning approaches which have some limitation. Acquiring a large amount of label data is time consuming, expensive. So the limitation is the data is flexible in the real world application where the label data is constantly changes. So this approaches faces challenges and scalabilities. Now proposed self-supervised learning approaches. Now the several techniques are using in self-supervised learning, particularly beneficial for information retrieval. One of the most widely used method, constructive learning, which involves the learning from distinct between the similar and dissimilar data. And another technique we are using, pretext task, which has predicting the missing word or phases within the document or estimating the data queries and the documents. Now, combining the other two methods we are using, constructive learning is the method within unsupervised hidden data that aim to learn a representation of data by distinguishing between the similar and dissimilar data. Next is generative learning method, which is the broader approaches where the model is trained to generate a new data which is similar to the input data. Now, achieve the higher precisions, recall and NDCG means normalized discounted cumulative gain. The precisions and recall and NDCG is often considered the hallmark of effective model performance. Precisions measure how the accurate a model predictions. Recall indicate the how many relevant instances it identifies. And NDCG assess the qualities of ranking predictions. Now, enable the domain agnostic scalable. in IR, information retrieval are crucial in helping the user to finding the relevant information from the big amount of the data. Domain agnostics means these systems can apply it across the different industries data types without requiring extensive domain-specific customizations. Scalability refer to the system ability handle increasing the amount of the data without significant drop of the performance. The rapid growth of the digital and heterogeneous data, they are the some kind of the data like text, images, and recorded structured data. Use this data in the fields of healthcare, financial, e-commerce, and research. Need to robust and scalable information. We require that. There is some traditional method we are using. First is constructive learning. Second is generative learning. Constructive learning is to gather the data from similar or dissimilar data. Generative learning is depending on the model, which is the output, which is belongs to the same to the input model. Yes, supervised learning is a part of the deep learning. Using the label data, so the data is very costly and time consuming. Data reducing the versatilities of the new data types. Self-supervised learning is managed data. In this we are using the two method, constructive or generative model. Proposed frameworks. In this we are using the multi-modal encoder using for the text, images, and structure, and unified loss functions optimization dissimilar and generative objectives. This is the literature review. In this we are using some model, CNN model. We explain. Now research methodology. The objective of this methodology is design a self-supervised learning method for scalable and semantic information retrieval. Some framework we are using constructive and generative frameworks, and the data is the text, images, and structured data. Pretext processing, using the text, we are using tokenization and masking. For images, we are using the cropping and flipping, and using the structured data, we are using the rounding and masking. Encoded method, using the text for using the transformation. Using the images, we are using the CNN. Conventional neural network is a special type of the artificial neural network designed to process and analyze the visual data such as the images and audio. This architecture inspired by the human brain and recognize the pattern images. And structured data, we are using the feed-forward networks. This is the type of the artificial network where the information moves from one direction, from input to output without any loop and feedback. It consists the input layer and one and more hidden layers and the output layers. Now the research methodology, in this some data are like face recognition, like images, like tabular data, like form data. This is the heterogeneous data. We are using some technique like text encoder, image encoder, and structure encoder. Okay, and some loss function, constructive loss function, VAE loss function, and MLN loss function, mask language modeling function. This is a robust presentation of the mask portion of the data input, especially target text and predicting marks word. Now VAE loss data is the self-supervised loss function that combine the principle of both self-supervised and generative learning and converting the semantic information. Now some data set we are using source. For the source we use the Kaggle, is the public and private file hosting on the Kaggle platform. This data set can be used for a wide varieties of the tasks. They can available in the CSV format, Excel format, JSON format, and SQL format. Some content we are using from the Wikipedia text dumps. There are the two folders. First folders containing the 99 files, and second folder containing the 77 files for the conclusions. Now each file presenting the portion of the raw Wikipedia data, dividing the processing, like concluding the precision for accurate result, assumption results. Some are here. Now the conclusion that the proposed is self-supervised learning method for scalable and semantic retrieval across the different data, heterogeneous data, achieving the high accuracy. Now the limitation is the less accurate data, limited data changes, and high costly of the data. Now the future works, we are working on the real world data and having the real world data adoption, improving the semantic alignment using the graph and the reinforcement learning, and the test across the large scale of data for the real world. Some references there. Thank you so much.
Thank you so much, Sir Virendra, for the presentation. Now we are open to questions. Okay, so I don't think so there's any question. So,
Okay, thank you.
okay, so now we'll be moving to the next presenter for the day. I would like to invite our fifth presenter for the day, presenting the paper titled Association Assessment Between Productivity, Business Execution Performance, and the Implementation of Technology under the code 396. I request Sir Ajay Jain to kindly take the virtual stage and begin the presentation. Okay, so Sir is not there right now. So we'll be moving to the last presenter of the day under the code number 414. So I would like to invite our sixth presenter, presenting on the paper title Securing Vital Workplaces, AR/VR Applications in Cyber Resilient Business Environment. I request Ma'am Catherine Catalan to kindly take the virtual stage and begin the presentation. Over to you, ma'am.
Hi, good evening, everyone. Namaste. So, in Tagalog, magandang araw sa inyo pong lahat. Yeah, good evening here in the Philippines, all the way from the Philippines. So, in behalf of my co-researchers, I would like to present to you our paper entitled Securing Virtual Workspaces, AR, or what we call the augmented reality, the virtual reality application in cyber resilient the business environments. Co-authors are Dr. Lavid, Dr. Valenzuela, Dr. Ditan, Dr. Dar, Dr. Shokon, Dr. Kazila, Dr. Dasik, and yours truly, Dr. Catalan. Again, a pleasant good day to everyone. So for the introduction, the AR and VR is transforming globally enterprise collaboration, but it introduced high-risk cybersecurity threats, including biometrics data, leakages, and unauthorized immersive manipulation. Current framework are not sufficient for these high-risk environments, especially in regions with evolving regulatory readiness. This study presents a zero trust and blockchain-enabled cyber resilience framework purposely engineered for secure AR and VR adaptation in global business ecosystem. So we have listed here some of our related literatures. Global work prioritized performance and usability, whereas few studies highlight regulatory heterogeneity, connectivity asymmetries, and workforce upskilling deficit that modulate attack surface and response readiness. Literature's posits convergence include identity is the primary control plane in immersive work. Telemetry from GAST, immutable explainable audit is required for forensic. Further, for the methodology, the research study, this study applies a design science approach, wherein we are analyzing the AR and VR threats, modeling a hybrid ZTNA blockchain AI framework, and validating it through simulation using detection and response matrix, as you can see in the figure 1. We are proposing the hybrid cyber resilience framework, also called HCRF. The HCRF, as you can see in the figure 2, is a layered AR and VR security model that combine zero trust access control, blockchain-based identity audit, and the AI anomaly detection to block immersive threats like phishing, avatars, and deepfakes intrusions. For the methodology, the AR/VR user begins by requesting an access through a headset and illustrated in the flowchart as you can see in figure number 3. The Zero Trust Network accesses the broker enforcers in continuous verification while each authentication is immutably logged on the blockchain ledger. Once verified, micro-segmented access is granted throughout the session. The AI monitors interactions and data stream, triggering alerts and containment of anomalies arise, ensuring adaptive cyber resilience. In a secure AR, VR workspace access, the headsets initiate the Zero Trust Network, or the so-called ZTNA, as you can see in the figure number 4. Listed here are the methodology. Of course, the step 1, we have to collect the user credential, capture biometric signature, verify device posture, compute for the contextual risk score, identify the validity, and once granted, access accepted, log in, and continuously monitor session for any anomaly and authentications periodically. Further, for the methodologies, as you can see in figure 6 and figure 5, blockchain-based identity ledger immutable authentication can access log the ledger, execute distributed consensus nodes, which validated credential, and append them to an immutable ledger, ensuring that replay or tampering is computably infeasible. Further, the AI, anomaly detection, real-time monitoring of the spatial interaction and data stream are all inputs, including the gaze, gesture, processing units, and outputs remediation or session termination. For the results, the AR and the VR cybersecurity risks in enterprise setting, the simulation reflected a spectrum of immersive threat scenarios, including phishing avatars, unauthorized data streaming, and deepfake impersonation. A threat landscape using a multi-layer risk model map attacks vector against confidentiality, integrity, and availability dimension, as you can see in figure number 7 and 8. For further evaluation of the emerging ZTO, and of course the blockchain mechanism, the ZTA, the blockchain were jointly deployed, the ZTE reduced unauthorized access by 90% through continuous verification, or the blockchain through a continuous credential play that attacked 98% accuracy. For the result, the validation of the hybrid framework for secured workplace patient adaptation, as you can see in the table 1, has 41% of improving the baseline security. The AI anomaly engine achieved 92% and 88% precision, detecting abnormal behavior within 2 seconds, critical for real-time AR and VR collaboration. This confirms that the HCRF effectiveness, delivering practical, layered cyber defense for enterprise use. And lastly, for the conclusions and future reworks, this study confirms that AR and VR workspaces are highly vulnerable to biometric and interaction-based cyber attacks, integrating zero trust, blockchain, and AI anomaly detection, and improving resilience by 41%, reducing replay and impersonation threat. The result validate layered defenses and effective for corporate and academic environments, with future work extending to healthcare and manufacturing for real-world deployment. As you can see, also listed are references. And to conclude my presentation, I would like to quote or to highlight Peter Drucker, one of our marketing guru. He stated that during our turbulent times, it is applying updated logic is nonsense. As a researcher, we must continue to research in order to improve the lives of mankind. Again, a blessed good day to everyone. Thank you for listening.
Thank you so much, ma'am, for your presentation. We are open to questions now, if any. So there's no any question? Okay. So we are at the end of the session and we completed all the presenter of the day. So now I would like to present the certificate of appreciation to our respected session chair, Dr. Paras Kothari sir. So I'm presenting the certificate right now. I'm just sharing my screen.
Thank you very much.
Thank you, sir. Is my screen visible, sir?
Yes, it is visible.
Thank you.
Okay. Thank you so much, sir, for taking out your valuable time to be with us today and for chairing this session. I'll be sending you the certificate soon after the event, sir. Thank you so much, sir, for the valuable time. And okay. So with that, we conclude today's paper presentation session at NICE TEAS 2025 Asia. So we sincerely thank all of our presenters for the valuable contribution and our audience for the active participation. A special thanks to our session chair for guiding the discussion with clarity and depth. So I would request all the participants present here to kindly switch on the cameras as we take a virtual photograph right now. So I request everyone to please turn on the camera. We'll be taking a screenshot. Yes. Wait a second. 3, 2, 1. 3, 2, 1. Wait a minute. One more. Last. 3, 2, 1. Thank you. Thank you, everyone. Thank you so
Thank you,
much for
everyone.
joining.
Thank you.
Thank you so much.